In this video, we are going to examine different types of carbon atoms. So we will look at primary, secondary, tertiary, and quaternary carbon atom. So first, primary carbon atoms. Carbon atoms are classified according to degree of substitution. That means how many other carbons particular carbon atom is bonded to. So primary carbon atom is bonded to only one other carbon. And so here we have several compounds, 3 compounds that contain primary carbon atoms. First one on the left is butane, and 2 end carbons, terminal carbons, are primary carbons. They are shown in red here. Middle structure is 2-methylpropane, and here we have 3 primary carbons. So 3 carbons that are bonded only to one other carbon. In this case, that would be central carbon. And finally, structure on the right is methyl cyclohexane. This is line formula. So now note how in a line formula primary carbon is shown. It's at the end of the bond. Finally, methyl group, or in this case methane, has only a carbon atom. Carbon atom is not bonded to anything else. Sometimes we classify this carbon also as primary, even though it's not bonded to any other carbon, or we may keep it separately, a separate classification as methyl carbon. Secondary carbon atom is bonded to 2 other carbon atoms. So in this structure of butane below, secondary carbon atoms are 2 middle carbons, 2 carbons inside the chain. Each of the 2 carbons is bonded to 2 other carbons. And when we consider methyl cyclohexane that we have just seen a minute ago, methyl cyclohexane actually has 5 secondary carbons. 5 of the carbons indicated here by arrows are all secondary carbons. Tertiary carbon atom is bonded to 3 other carbons. So here we have again example of the compound we have seen before, 2-methylpropane, and this middle carbon that is bonded to 3 other carbons is actually tertiary carbon. That's also shown in red. Carbon of methyl cyclohexane that is bonded to methyl group is also tertiary carbon. That carbon is bonded to 3 other carbons. Again, note how tertiary carbon is indicated in a line formula. And of course, quaternary carbon atom is carbon atom that is bonded to 4 other carbon atoms. So in this example, 2,2-dimethylpropane or neopentane, middle carbon is quaternary carbon atom, and it's bonded to 4 primary carbons. And in the example on the right, that would be 3,3-dimethylhexane. Carbon 3 is quaternary carbon. Again, note in a line formula how quaternary carbon is represented. These designations, secondary, tertiary, are sometimes used in nomenclature of alkyl substituents. We already covered nomenclature of alkyl substituents, and you may recall that we name alkyl substituents after the name of the corresponding alkane with the same number of carbon atoms, by dropping A and E suffix of alkane and replacing it with YL to indicate that it's an alkyl group. So CH3 would be methyl group, CH3, CH2 ethyl group, or in general, R is symbol for an alkyl group. When there is branching, we may use additional symbols. So symbol N actually indicates that there is no branching. Symbol N, for example, N-propyl or N-butyl, would mean normal or straight chain propyl or butyl. This is a little bit obsolete, and these days we don't use symbol N anymore. Simply, if we don't use any symbol, it implies that chain is straight chain. Symbol S, in parentheses, there are all the obsolete symbols that are not used anymore, like sec for secondary. Symbol S is used for secondary. T for tertiary. That means that bonding is to secondary or tertiary carbon atom of that substituent. Symbols N, which I said is obsolete, not used anymore, but S and T are commonly used. So symbols S and T are separated from the rest of the name by a dash. There are 2 other symbols, iso and neo, that also indicate substitution of carbon atom that is bonded to rest of the molecule. And those symbols are used as prefixes. They're not separated from the rest of the name. So here are some examples. Straight chain propyl or butyl is simply named as such, as propyl or butyl. But if there is branching, then we use, in this case, prefix is isopropyl. Prefix iso means that in a chain on carbon next to last there is methyl group. So here we have two carbon chain, and CH group is carbon next to last, because CH3 is the last carbon. And on that there is methyl group, so this is isopropyl. We could also name this as secondary propyl, because this CH carbon is secondary carbon. But this is the nomenclature, we name it isopropyl, so we don't use term secondary propyl or S-propyl. That one is simply not used. So it will be wrong to name this as S-propyl. It's simply a convention, so there is no particular reason why this is correct or not. It's just a convention. So it's isopropyl, and you need to memorize it as such. Then on the right you have isobutyl, so you have a bit longer chain of 3 carbons, and on carbon next to last methyl group, so isobutyl. And then S-butyl, that's straight chain, unlike isobutyl, which is branched. Iso chain is always branched. Of course, branched because branching is on carbon next to last. S-butyl, that's straight chain, but bonding is to secondary butyl of the chain. So note the difference between butyl and S-butyl. Chain is the same, straight chain, but butyl bonding is to primary carbon of the chain. S-butyl bonding to secondary carbon of the chain. Isobutyl, that's branched. And then T-butyl actually is same type of substituent as isobutyl, but bonding is to different carbon. Now bonding is to tertiary carbon. In isobutyl, bonding was to primary carbon. In T-butyl, bonding is to tertiary carbon. That's what this T indicates, that bonding is to tertiary carbon. And finally, one more substituent you need to know is neopentyl. Neo means that on carbon next to last there are 2 methyl groups. So iso, on carbon next to last there is 1 methyl group, neo, 2 methyl groups. So neopentyl, total of 5 carbons, and on carbon next to last there are 2 methyl groups. Again, bonding is to primary carbon. And this ends this brief video on primary, secondary, tertiary, quaternary carbon atoms. And next we'll learn more about nomenclature. We'll look at nomenclature of compounds that contain functional groups.